Okay, what we want to do now with our binomial theorem is do a process. We want to find in any expansion what would be the greatest coefficients or the greatest terms given a value of x in our expansion. So before we start looking at the process of doing that, what we want to do is make sure we're clear on a few terms. So and we've got 1 plus 3 x to the power of 4, and if we want to talk about our terms in this one would be the first term, and that's where we got for coefficient of 4c0. So 4c0 is the first term, then 4c1 is the second term, and then through to the last term, which is actually a fifth term in this way. Remember, if we've got power of 4, we're going to have 5 terms. So the fifth term in this one will be 81x to the power of 4. So we want to make sure we're clear on that terminology. The first term will be 4c0. The second term is 4c1. So if we look at the number there, it's one less than what the actual number term we're talking about. So keeping that in mind, if we want to consider our expansion of 3 plus 4x to the power of 15, what we want to do is compare. We want to go along a process of comparing terms. If we're going to get a greatest coefficient, what we want to do is have a look and go, well, in our coefficients here, in this one, you look at here, 108 is the greatest. So it must get to a point where it's where the coefficients get the greatest, and then they start to get smaller. So unless it's at the end, but well, if we go start comparing it, what we notice is that the coefficients are less than, or the second coefficient is greater than. What we want to do is keep going along until we get to a point where it's not greater than the one before. So where is the term greater than the coefficient of each term greater than the one before? So we should be able to do that algebraically by comparing two terms. What we call the rth term, which would be 15c r minus 1, and the 3 to the power of 15 minus r minus 1 times the 4x to the power of r minus 1. So just again, we're applying the NCR formula with as a general formula of the general coefficient, general term of a expansion, binomial expansion. And also we're going to consider the r plus 1th term, which is 15cr, 3 to the power of 15 minus r, times 4x to the power of r. So notice the r plus 1 term is 15cr. The rth term is 15c r minus 1. So if we clean this one up a bit before here as well, 15 minus r minus 1, the 15 minus 1 gives us 16, and then we still got the minus r. So that's where we get the 16 minus r. So let's start comparing them. We get a ratio between them. Basically it means get the ratio and get the fraction there. We're going to ignore the values of x. So notice here we've got the 4x in there, but if we're just looking at the coefficients, we're going to ignore the value of x. So notice we've dropped the x's out because we're just looking at the coefficients. So in that case, what we're going to do is start to clean it up. We need to do some comparison. So we're going to get the 15cr, which is, there's 15cr there, 15 factorial over r factorial minus 15, times 15 minus r factorial, over 15c r minus 1. 15 factorial, r minus 1 factorial, 15 minus r minus 1 factorial. So we've got that there. Cleaning these parts up, 15 to the power of 3 to the power of 15 minus r, if we compare that and 3 to the power of 16 minus r and do our subtraction, do our division, basically it's going to be a subtraction of the powers there. So 3 to the power of 15 minus r minus 16 minus r gives us 3 to the power of minus 1. 15 minus 16 is minus 1. Minus r plus r gives us 0. So it works out as 1/3. So that's where that 3 is coming in there, because it's going to be the 1/3. So that's going to cancel out. That goes in once. That gives us 3 there. Same thing here. 4 to the power of r minus the r minus 1 would cancel out and leave us with the r minus r cancels, and 0 minus minus 1 gives us 4 there. So that's where we get the 4 on 3. That's where that's coming from. 4 to the power of r divided by 4 to the power of r minus 1 leaves us with the 4. 3 to the power of 15 minus r over divided by 3 to the power of 16 minus r gives us 3. So we leave that there. Looking at these ones, well, the 15 factorials will cancel. there. And then we've got the 1 on r factorial, 15 minus r factorial, divided by 1 on this expression here. And again, 15 minus 1 gives us 16 minus r. And so when you divide by a fraction, you actually multiply by its reciprocal. So that's why it ends up being on top. R minus 1 factorial, 16 minus r factorial, over the r factorial, 15 minus r factorial. So what's going to happen is we can start to clean it up. So the r factorial and the r minus 1 factorial cancels, leaves us with the r. 15 minus r factorial, well, that's 1 less than 16 minus r factorial. So that cancels and leaves us with the 16 minus r. So that's where we get that expression. And so the ratio that we get in terms of r would be 4 outside of 16 minus r over 3r. So that's cleaned up. That's what we start with there. That expression comes down to being equal to that. So now what do we want to do for it? Well, the greatest coefficient's always going to be where the r plus 1th term, so the next term is over the previous term, is greater than 1. Once it starts to go be less than 1, we know our coefficients are getting smaller, so it won't be true. So what we want to do is solve this one. So we know r is going to be a positive, must be a positive number, so we can multiply by 3r without a problem, without changing the sign. So r is going to be a positive number. So it's not a hassle to multiply by 3r there. Expand our bracket out, 16 minus 4r greater than 3r. Add the 4r on both sides, so that's where we get the 7r. And then divide by 7. So r is going to be less than 9 and 1/7. So if r is going to be less than 9 and 1/7, that means r would be equal to 9. So if r is going to be equal to 9, it's going to give us the 10th term, which means we get 15cr, 3 to the power of 6 times 4 to the power of 9. So because that's from our general term of our expression. Again, we're just looking for the greatest coefficient. We're not really worrying about what the x to the power would give us an x to the power of 9, but we're not even worried about that in this situation, which means we get, when we put that into the calculator, it comes up as a scientific notation, 9.6 times 10 to the power 11. It's a pretty large number. That's a pretty greatest coefficient. So there's our process. We need to get our fraction, our ratio between the r plus 1th and the r terms, and get an expression for it, set it greater than 1, and then find the value of r that's going to be. So r is going to be less than 9 and 1/7, which means we've got to go to a whole number. Remember, r is going to be a whole number, can't be a fraction. So it's less than 9 and 1/7, which makes it 9, and then we can do a substitution to actually find that greatest coefficient. Have a look through, be careful about your algebra. Lots can go wrong here. So that's a lot of work, and that's really complex working. So take a lot of care with all that work.